Hi, this is Mr. McGovern and welcome to the third video in the Projectile Motion series. It's really important that before you watch this video, go back to the second video in the series, which wasn't me, it was Alan, who was dropping a billiard ball and pushing a billiard ball to the right at the same time. And there's the link. I'll put the link in the description as well for you to go and visit that video. Here's a screenshot from that video, and I've superimposed all the pictures of the ball. Each ball, the left one's falling vertically down and the right one's pushed out to the side. And really important point here is when you get your ruler and put a mark through each ball, you'll see that they line up. Even though the one to the right is still moving to the right, it lines up every split second with the ball falling vertically down. And it's a really important observation, is that if you just think about the right ball and its movement downwards, it lines up with something that's just free falling. So the ball moving on the right falls at the same rate as a ball falling directly downwards. So this video and the first video you watch, you come up with two observations. And the first is the horizontal part of a projectile's motion moves at a constant velocity. Okay, so that was in the first video of the basketball shot, and you saw that horizontally the ball moved the same distance each split second. The observation from the second video, which we're talking about now, is that the vertical part changes velocity. Now, when the basketball was moving upwards, that velocity was slowing down. When this billiard ball is moving downwards, it's speeding up. Get it back there. You can see that each of those red lines has a bigger and bigger gap between them. And the second thing is, not only does it speed up, but it directly matches a falling object. Okay, so we're going to change the word part or bit, the horizontal part or horizontal bit of the velocity, and we're going to call that component. So the two rules of projectile motions we have, and this is basically all of projectile motion, the rest is just adding maths to these rules. The first is that the horizontal component of a projectile motion moves at a constant speed. Okay, so that's the horizontal part, which was observation one. And the second is that the vertical component of the projectile motion accelerates downwards due to gravity, and we know gravity, G equals 9.8 meters per second squared.